Hello, you little chicken hawks. Hopefully you have done all right on your single replacement reactions for day one. That was really where you're just taking one of those ions and replacing another one. We just needed to add a little bit to day two to make it a little more in depth. So the thing that you need to understand actually is in this thing that's attached on Canvas called your reactions help sheet. Hopefully you've learned how to use it a little bit, but on the front of it, the very, very top, there's some things about soluble and insoluble. We actually want to scroll down a little bit to where there's these arrows. This is called the activity series, and I believe the other video we posted mentioned this, but it's a very important list that explains to us how reactive a certain metal is and if one metal will replace another one. So normally in class what I have you guys do actually is take this out, and what we do just to remember is we label the whole arrow itself. So any metal on the top is very, very reactive, and what that means is it will replace anything else. So a lot of times next to lithium up here, we come write something like Zac Efron or somebody who you guys think is good looking, because that will always win. Things towards the top are very, very active metals, and they'll replace other things. A lot of times what we do then is we come on the bottom here next to silver, platinum, and gold, and we write something ugly like maybe a Carter Newell or something. Something that helps us remember these at the bottom are very ugly and nobody wants to be with them. That's also one of the reasons why you'll notice these three things are part of a lot of jewelry, because they're not active at all, which means if I leave a piece of iron out in the rain, I know that it's going to rust because it's actually fairly active. If I leave gold out, it's not going to rust over time because it's not very reactive, which is why so much jewelry is made of that. You'll want to keep this bad boy out as you go. You'll notice hydrogen's not on your left sheet, but it's right below tin, so you can go add it right there. Now, how to use this, though, is we're going to keep it on the side right here, but if we come back to the example we did the other day, you can see right here, bromine was the one that had the choice because we have a positive metal, a negative, and a positive. So technically, bromine has to choose between silver and magnesium, and if I come over here, silver's down here, magnesium's right here. So magnesium is higher, which means it's better looking or a more active metal, which is why bromine chose to go with magnesium. If bromine has a choice, it will always choose the higher one, and that's why we call this the activity series, because it shows us which one is more active. That's why it would leave silver, though. Silver's way down here. To show you a really important example of this, let's say that we had potassium bromide react with pure silver. Okay, so if I go look here, I know in my compound that potassium is +1. Oops, I don't know what I just did there. Bromide is -1, so we have KBr, and it's going to react with pure silver, which is Ag, but I know in a compound it would be Ag +1. So the way that I show this is I go show, okay, well here's Mr. Bromine. Mr. Bromine is currently with potassium, which is right way up here, really good looking, like an 8 out of 10. Or is she going to choose to go with silver, who's way down here? Terrible personality, ugly. Well, that answer is pretty easy. Bromine will stay with potassium because it's higher on this sheet. So how do we show that? Well, it's already with who it's going to stay with. Potassium is way better looking than silver. So the way that we show that is we write no reaction. And what that means is bromine is already with what it's going to be with. It would not leave active potassium and go with ugly silver. So we write no reaction because if I dropped a piece of silver in that solution, nothing would happen because bromine has already been with the most active metal and it wouldn't leave to go with ugly silver. Kind of some dorky analogies, but that's the way that you'll use this, and you'll see this no reaction on the answer key a few times. Good luck and ask for help if you need it.